And then I think that brings us on to Martin Greenhow, who's going to talk about some work that he's done with many PhD students over a number of years on the maths EG system, which I think is also definitely worth looking at. So Martin, always a pleasure to have you involved at any event. Over to you.
Okay, can you actually see the slide, or just me? You can see the slide, right? Great. Okay, it's interesting that both previous speakers talked about formative assessment, and that's what I'm going to talk about too. This is a great way of learning. I imagined that being such a great lecturer, my students would come out of lectures fully formed and be able to do questions. How wrong can you be? How naive can you be? They come out knowing nothing, and they get in an e-assessment system, they get their hands dirty, they make mistakes, and crucially, they read the feedback. And that's where they're actually learning the mathematics, often for the first time. They come out with a vague sense of, well, he must be important because he went on about this quite a lot. But actually doing the work and getting your hands dirty e-assessment is a very good way of forcing the issue. Collaboration is also good, since there's randomization and all the rest of it. But the key thing really is feedback. And students learn the topic from the feedback. And then if they're sufficiently interested, they go and read the theory, the underlying theory. Probably not the other way around. They don't do theorem, proof, corollary, and then examples. They do examples, and then, oh yeah, okay, I see how it works. Why does it work? That's where then you've got them where you want them then. So if I can just go on. This is where the website exists at Math Centre, and it will continue to be there for, well, as long as Math Centre exists, I guess. I'm quite interested in the database spanning GCSE to A-level undergraduate topics, of about this sort of interface between school and university is where I'm really most interested. Partly because I ran the foundations course at Brunel for many years. Adult learners are also quite a big area. It's not the same as school numeracy software where the language is targeted towards kids. And if you give that to adults, they're not going to be very interested in Freddy Frog jumps 5 lily pads forwards and then 2 back. Well, how far has he gone? They'll be more interested in what's my tax deduction, etc. So there's a whole range there of possibilities, and I think that some of the learning stuff needs to benefit from the developments in the maths community and exporting the sorts of things we can do down to not the school level necessarily, but to this adult learner and employability aptitude type tests as well. There's actually not 6,000, there's 4,000 question spaces. So if you want to go leave in a huff, please do so. I miscounted them. But there are multi-choice questions, and then you've got numerical input. And I like multi-choice questions because you're asking students, do they recognize the right answer if it's shown? Do they recognize it when it's there? And that's a skill, but it's not the skill you want. Ultimately, you want them to be able to, given a blank sheet of paper, do this question. But to build their confidence, then they get some marks using multi-choice questions. You also have MAL rules, which Christian was talking about, common errors, he was calling them. And these can be coded up so that the options in the multi-choice, the distractors, are not just random thoughts. They arise from structured but incorrect ways of doing that question. And then you have also that in responsive numerical input, where these MAL rules are coded up behind the scenes. So it checks, is the question right? Is their answer right? Or did they, if it isn't, then it drops through to the next level, which is, did they make this error? Did they make this error? Did they make this error? And eventually it drops through and says, I don't know what you've done, perhaps you're guessing. And the students throw up their hands and say, I was guessing, how did it know? They're rather surprised by that sometimes. So responsive numerical input questions, such as we've seen, are a good way of having as many MAL rules as you want. And it could be as simple as you've got your calculator set to degrees mode, you're doing calculus, it should be radians mode. You've got positional numerical input, where the error moves around, or the thing that you're selecting moves around a formula. True, false, undecidable. This is, I'll show you one of those in a moment. Numerical input plus confidence. This is quite a devilish sort of question. You give the answer, okay, how good are you, how confident are you that that's the correct answer? And you put the boot in if they're wrong, but they're confident in it. You also have revealed multi-choice questions, where they're offered the first option, and then if they reject it, they never see it again. And they keep going until it drops through and says, well, you didn't select anything. And those are pretty scary questions to do. And the new one that I'll show you is statement selection questions. I'll explain that when we get there. There's a lot of commonality in all of these questions. And so you get the same sorts of questions, particularly in algebra and numbers, and also in other areas. Although I have to say, I've been dabbling in biomaths questions, and it's extremely hard for a non-biologist to author the feedback because I don't know enough of the science. When I was doing the questions on nursing calculations, I actually worked with a senior lecturer in nursing, because she would say things like, you don't give that drug to children. It doesn't come packaged like that. Syringe drivers only have 15 or 20 drops per minute. Those sorts of clinically correct things give the question a sense of realism. So I actually spent a lot of time undoing the randomization in the question. I said there's a lot of commonality. Here's an engineering syllabus, and you don't need to read this. You just need to know, look at the colors. The white stuff I'd already done when I was asked to do this project. The new bits were added as appropriate. And there are some bits here which I don't think you can do yet convincingly in eassessment, although I stand to be corrected with this, to do with proof. Basically, proof is a thing which is about value judgments. Have they really justified this to some extent? And what do we assume? What can we assume the students know? Where are they coming from? What are they deducing from that? So that's sort of, if you give any sort of first year engineering syllabus to numbers or stack or DEWIS or MathCG, a lot of it will already be there. So as I said, don't go, as was said, don't go reauthoring, reinventing the wheel. We don't need more questions on general quadratic formula, for example. Here's a question, quite an old one now, about statics, and this is all about moments, and there's a lot of feedback here. And when the PhD student Mundy Gill wrote this question, I said, you've written too much feedback here. They won't read it. And how wrong I was. The students spent most of their time studying the feedback. We observed them surreptitiously, and they do 2 or 3 of these questions in a session of 50 minutes and spend more than half of that reading and studying the feedback and identifying where they'd made their mistake. So that's really a good way of learning. They also tend to mimic the layout of the feedback that you get in their own exam scripts. And we look for that, even if it's just mundane things like, were the vectors underlined? Do they understand what a vector is? So those sorts of things, there were sort of benefits which we hadn't really expected. Here's a question about spot the error. Which line is the error in? Now, students, if you ask them to do the partial fractions of this rather complicated expression here, they will use Wolfram Alpha or some such system. So you don't really want to ask them what the answer is. You want to say, here's Fred's attempt. Well, it's Bruce's attempt at the moment. And Bruce is a randomized name too, from a database of likely looking names, male and female. And you ask them which line the error's in. And so they are responding to this. They do need to know some mathematics, but again, it's not the same as give them a blank sheet of paper and deduce what's going on here. Partial, it's a bit like having a car. It doesn't do everything you want, but what it does do, it does extremely well. Here's a statement selection question where I'm saying, this is a new question, and we're looking at the intermediate value theorem, and I'm saying, this is the intermediate value theorem. Which of these statements must be true if the function has the intermediate value theorem? You can also say must not, which is a different thing, or may, and that's so there could be variance on this. What I haven't done really is written enough feedback on this. I haven't given them counterexamples if they choose the wrong thing. And what they also need to do is get all of the answers correct and none of the, well, they need to select all of the correct options and none of the incorrect versions. Otherwise they get 0. So it's a mastery question. Randomization is there. There are 8, 9 options here. It's usually between 5 and 10. And the number of correct statements could be 0 or it could be all of them, and ditto conversely the incorrect options. So these are quite powerful questions, and really I haven't tested them with real students. I think they will find them extremely difficult to get the marks for this. Here's a true-false question about what happens. It's a bit like pre-calculus. What happens here when R and S increase or decrease? And this is much more challenging if R and S and K can be negative as well. So they really need to understand what this formula is saying. You're not asking them to do anything. You're just saying, here's an expression or an equation. What does it mean? Here's a rather more straightforward question on logic, and these are logic gates. All I want to point out here is that you can piece these together a bit like a printed circuit, and you can then put up any sort of thing you want, although the topology is fixed. Here you've got 4, 2, 2, 1. So that's not randomized, but you've got different versions which give you different options there. Graph theory is also covered. So go and have a look. We can also ask questions, okay, can you actually do this question? How confident do you think you might be? And they have to drag and drop in no knowledge, very confident to very confident. And you could then say, okay, do some intervention and see how their confidence changes later on. It's not really marked, it's just for their own benefit. And statistics, well, skip over that, but you're just asking them, how do you use this table of the cumulative binomial distribution? Okay, so we all looked at this, and there are various ways of embedding. I'm running out of time, so I won't go into this. But what I wanted to do was show you this graph, rather busy graph, and we introduced computer-aided assessment in the 3rd year in from the left, the green arrow, and you notice that the exam average also increased, but more importantly, it stayed pretty constant until they changed the entry requirements for these 200 or 300 economics first years. And then, of course, they didn't have A-level maths, all of them, so the average dropped. But basically, it's gone up a lot, and it's hard to see of any other intervention which would consistently produce a 10% increase in the average mark on a traditional unseen written exam. So this exam average is not an artifact of the marking scheme. It's comparing like with like. There's also been a change in lecturer, so it's got nothing to do with me. Like, we talk about Mal rules, that's been a study recently, and so you can go and try this. Now, what I really wanted to do was show you how you can do this as a learning resource. What you can do this afternoon, if you want, is to link in any of the Maths EG questions by simply cutting and pasting the URL at the top of the screen into your learning material and saying, try one yourself, and here's the link. And they would click on that and they would see this question with the feedback, and then they could try new questions, new versions of this question. You could also link to individual topics by putting in the URL at the bottom and changing the PID, the parent ID, and this one is 40, Algebra Understanding Expressions, but it'll be some other ID, and it's displayed up in the right-hand side of the screen there. So that's trivially easy to do. You do need to do no work whatsoever to enhance your lecture material. Anything that supports a URL, a web link, will do it. Even other e-assessment systems could have this in as part of the feedback. So that's where I need to stop, and be happy to take any questions.
That was brilliant. Thank you, Martin. And despite all your worries that you might run over, not even in the slightest. So so thank
Well,
you.
I could have gone on for another 2 hours if you'd wanted, but not.
Well, I heard a rumor you could go until it got dark, but that's a separate thing. But any questions there for Martin? Anyone would like to ask? As I say, MathCG is a wonderful resource, and I think that the key point you highlighted, Martin, was the role that your PhD students have had over many years, kind of contributing to its development.
Yes, that's right. And not only that, undergraduate and MSc students too have taken on topics, and they say, you know, typically, oh, I want to do calculus, and you say, which bit of calculus? And it turns out in the end, they're doing the chain rule, something like that, and making a really good job of that. So it gets very atomized, and you build it up over many years. This has been going on since the, well, year 2000, in fact. So yes, it's very sweaty. The question I showed you, spot the mistake, those are extremely onerous to do, because you have to code behind the scenes different versions of the question in case they are used by a random selection. So those questions are pretty onerous to write. But once you've written them, they're there forever. Well, as long as the system is around. So that's the real advantage. You're going for the long term there.
So any questions or comments for Martin? If not, I think in that case, Martin also deserves one of our TALMO rounds of applause. So again, thank you, Martin, for contributing. And if you haven't checked out MathCG or numbers, then please do take some time to have a look, because I think there's some wonderful resources there. And I think what today has shown that, the real care and thought that's gone into developing those over many, many years. And I think we should all be very grateful for colleagues who are doing that. Any questions for any of our speakers? I know Christian's been picking up a number of things in the chat, but I just wondered if anyone had any final or closing questions that they wanted to ask of any of our speakers.
Does that mean everybody's satisfied or bored? That's
I think, well, there are a lot of people still here, so I think that must mean that everybody is very satisfied. I think that's the conclusion we would reach on module feedback forms, Martin.
I think one of the things which I think all of the authors of these systems would appreciate is feedback and suggested topic areas, because we don't necessarily know, especially if it comes from chemistry or biology or some other area. And I mean, MathCG, for example, is particularly strong in economics because I taught that for years. But other areas very suitable for objective tests in general, and particularly in computer tests, if you can use randomization with them. So definitely feedback there, suggestions. No promises, but I'm retired now, so I've got to have something to do in the long winter evenings, and whatever I do would be publicly available.
And I think, as Ben says, satisfied 5 out of 5. So clearly, I think it's done a good job. But I think, again, just to say, please do check out some of these resources. I think the focus clearly today has been on the formative assessment side. I think we focused an awful lot, and I think it was Christian who said it in his abstract, that we focused an enormous lot on the summative side of things when we went into the various lockdown. I think now is a real opportunity to think about how we can use freely some of these systems to support our students with their formative learning. Chris, is it too early for you to give a mention of your future e-assessment in the your regular kind of e-assessment conference? I don't know whether I put you on the spot there, but there's a sort of the annual meeting that typically runs. Is that appropriate?
I think it will happen in it's usually June after most people's exams finish. Yeah, can't see why it wouldn't happen again. Yeah,
so I put you a bit on the spot there, but I think more just to flag to colleagues here who are really interested in using e-assessment and the opportunities that, there's been a great meeting that's run in Newcastle for many, many years now. And I think, do look out for those sort of activities there, because it's a chance for everyone to come together and share systems.
Christian's posted a link in the chat there. That's worth checking out. They've got recordings of previous talks and that sort of thing as well. So you can check that out.
The conference is called Ames Assessment in the Mathematical Sciences. Since the first couple of editions, which happened physically in Newcastle, we moved entirely online, and we're sticking with that. And it's now annual. So yes, as Chris said, all the recordings of previous talks are online, and we will run it again this year. But starting that organisation is a problem for January.
Yeah, and I think as Chris said, I think he introduced the verb to TALMO, and I think apologies, Chris, I TALMO'd you then by putting you on the spot. So my apologies with that. But again, I think a serious point that is a fantastic conference and a fantastic set of previous resources as well for anyone who's interested. So I think unless there are any other closing comments, I think we end it there. I think we thank Christian, Chris and Martin once again for fantastic contributions for really kicking this off, and I think there's been real interest in this, so please do explore this, do follow up with them directly. I'm sure they'd be delighted to hear from you. But thank you all once again, and thanks for everyone who's attended today, and see you at the next TALMO event in a few weeks' time in December. Thank you.